now we're looking at the standard or vertex form of a parabola. We're asked to graph x equals 3 times y minus 1 squared plus 2. Process is the same. Again, we're looking at x equals a times y minus k squared plus h. hk is still the vertex. A is the leading coefficient. In this case, a equals 3. Since that is greater than 0, we know that the parabola opens to the right. It opens in the positive direction. So a equals 3, parabola opens to the right. We know that the vertex is hk. In this case, h is just 2. K, remember it's y minus k, y minus 1, so it's 2, 1. Which also means that our axis of symmetry is y equals 1. Let's go ahead and graph that. X equals 1, 2, 1. Go ahead and give our scale here. So we have our vertex. We have our axis of symmetry, y equals 1. And then we also can look for our intercepts. We know it's opening to the left, so we know it's going to have both y-intercepts and an x-intercept. So if we look at the y-intercepts first, that's when x equals 0. So 3 times y minus 1 squared plus 2 equals 0. Subtract 2 from both sides, y minus 1. 3 times y minus 1 squared equals negative 2. And then y minus 1 squared equals negative 2/3. Well, wait a minute. That can never happen. We will never have any value squared, any real number squared that will equal a negative number. So there is no y-intercept. No y-intercept. And that makes sense because I misspoke earlier when I said it opened to the left, so we'd have y-intercept. We already know it opens to the right. A equals 3, which is positive, so it opens to the right, which means there's not going to be a y-intercept. The x-intercept, however, when y equals 0, 0 minus 1 squared is negative 1 squared. So let's go ahead and substitute. 3 times 0 minus 1 squared plus 2. That equals 3 times negative 1 squared, which is 3 times 1, which is 3 plus 2, which equals 5. So that means the x-intercept is going to be at 5, 0. So 1, 2, 3, 4, 5, 0. So that means there's also going to be a point at 5, 2 on the opposite side of the axis of symmetry. So then we take our vertex, our x-intercept, and the point that we found using symmetry to graph our parabola. And then if we wanted to check it again, we could substitute a couple more inputs to check the output. And inputs being y, even though that seems a little backwards, but we have an equation that's in terms of y.